Okay, today we're going to talk about partial quotients without remainders. So this is going to be a really different way from the traditional algorithm. You're going to get the same answer, but it has a different strategy to it. And it's kind of interesting because you can pull out anything that goes into it evenly. And you can kind of keep pulling things out to get it down to the answer. So here's kind of, let's go through a couple of problems, and I'm going to do each problem two ways so that we can kind of see how it works and how even if I pull out different things that you can get you can get the same answer, but in a different path. So if we look at this number, we're taking 6,545 divided by 5. So when I look at this, if I look at this thousands place, I know that 5 times 1,000 equals 5,000. So I'm going to put my 1,000 over here. So 5 times 1,000 would be 5,000, right? Everyone agree on that, right? So we've got 5. So now we're going to put this 5,000 here, and we're going to subtract to see what we have left to figure out, okay? So now, couple of different things we could do. I could look at this front number here, 15. I know 5 goes into 15, but this is 1,545. I know that 5 times 300 would equal, and I'm going to actually erase that line there so it doesn't confuse us. 5 times 300 would equal 1,500. Okay? So then I'm ready to subtract. I'm down to 45. And I know that 5 times 9 would equal 45. And then I'm down to 0, which means this goes into this number evenly. And if we think back to our divisibility rules, since this number ends in a 5, I know that there will not be a remainder. So my answer is when I actually add up these numbers over here on this side. Okay, so when I add these up, and you want to make sure you line up your place values here, because if you don't line up your place values, you might add the wrong place value and you might get a different answer. So 0 plus 0 plus 9 equals 9. 0 plus 0 equals 0. 0 plus 3 equals 3. And 1 is 1. So that is our answer. If we want to double check it, we can do 1,309 times 5. So 9 times 5 is, 45. I was about to put my 4 down at the bottom. 5 times 0 is 0, plus 4 is 4. 5 times 3 is 15. How did it go to my eraser? 15. 5 times 1 is 5, plus 1 is 6. So you can see that we get the same number that we had underneath, okay? So that's how that is going to work. Now, this is one method, one pathway to get there. So I might do this. My neighbor might do something. We've gotten to the same answer, 1,309, in two very different ways, really different. So here's the problem again. So what I could do, let's see, if I look at this problem and I think, whoa, that's a big number, not so sure what I can do with it yet. However, I can look at this back number here, and I know that with my facts of 5, I know that 5 times 9 equals 45. Okay, so, hang on. Nope, I'm good. Okay, sorry. So now I'm going to subtract this. I'm going to extend this a little farther. That was what was messing me up. Okay, so I get 6,500. Now, if I look at this number, I can kind of look at this 500 here, and I know that 5 times 100 equals 500. So I'm going to get rid of that line again here so it doesn't distract us from our problem. So 100, I'm taking this 100 over here times this 5. 100 times 5 is going to equal 500. And now I can subtract this, and I get 6,000. Okay, so now I know that 5 goes into 6,000 how many times? 1,000 times. And 1,000, just like we talked about in the last problem, 1,000 times 5 is 5,000. And now when I subtract this out, I get 1,000. So now I've got 5 going into 1,000. So if I look at these front two numbers here, 5 goes into 10 twice, and there are 2 zeros after it. So I've got 200, right? So 5 times 200 would equal, you guessed it, 1,000. So I end up with 0, right? So if I add these up, 9, 0, 1 plus 0 plus 3 is 3, and a 1 in the thousands place. So as you can, but did we get to the same answer? You bet. So we're good to go, right? All right, let's try another problem. So my strategy is usually to look for that front number and see how I can get that thousands kind of whittled down. So that's sort of the strategy I follow, but your strategy might be different. So 2 goes into 8,000 4,000 times. 2 times 4,000 equals 8,000. Then we subtract, and we end up with 674. Okay, so I'm going to look for my biggest place value again. 2 goes into 600 300 times. 2 times 300, right? 2 times 300 will equal 600. And then I'm left with 74. So you can see you kind of are able to like get these large, big place values out of the way, and then you're down to a smaller number. Okay, let's see. I know that 2 times 30 is going to equal 60, and then I'm left with 14. And then 2 times 14 is equal to 7. Or sorry, not 2. 2 times 7 is equal to 14. Excuse me, I'm sorry. So 7 times 2, right? 7 times 2 was 14. And now we're at the end of our problem. We've got a double 0 down there, and we're ready to add. So 0 plus 0 plus 0 plus 7 is 7. 0 plus 0 plus 3 is 3. 0 plus 3 is 3. And 4 is equal to 4, right? So we get 4,337. Now again, if we look at our two ways, there are a couple of different strategies. There are multiple. The two strategies I use are not even the only ones. So whatever strategy works for you, however you're going to pull out the numbers, that is how your partial quotients works. So it's a little different than the traditional algorithm, but give it a try. More than one way to get there. So let's give it a try. We could, let's see, what should we take out? Let's just take out this. Let's do 2 times 2 is 4. Awesome. Sometimes you're stumped at the beginning and you're thinking, all right, where am I going to start? Start wherever you can. Okay, then I could, then maybe I'll do my hundreds next. So 2 times 300 equals 600. Okay. Now I've got 8,070 left, so I could either look for the 70 or look at the 8,000. I don't know. Let's see. I know that 2 times 5 is 10, right? So I could pull a 5 out of there, right? 2 times 5 is 10. So then I end up with 8,060. Let's see. If I want to get rid of this 60, 2 times 30 would be 60. I could get rid of that. And then 2 times 4,000 equals 8,000. And we are down to 0. Okay, so now we add this up. 2 plus 5 is 7. 0 plus 3 plus 0 is 3. 3 plus 0 is 3. And 4 is 4. So 4,337. I didn't do a great job of lining up my stuff on that one. It was a little smushy. So just make sure you're lining up your stuff. But all right. So there are lots of different ways, and you might even be able to think of a totally different way of this